Number 2, the theta is 60 degree and use it in the flux equation. Again the same. Initially phi r 0.866 phi m. Here that 60, that's you write 0.866. The previous 0, you write the reference is 0. Here 0.866. Next minus 0.866 phi m. Here the phi b is 0. Phi b is 0. Here also same 30, 60, 120 difference. Again depends on the direction. The phi r is positive, phi y is negative. Hence the phasor diagram as shown in the figure. As a same geometrical construction, it can be seen that the total flux is again same, previous 1.5 phi m. But through the magnitude of the total flux in the same, it is rotated through the 60 in the space in the clockwise direction. Similarly, phasor diagram is a drawn of various values of theta. It means 30, 60, 120. The difference between the angle, the always equal to magnitude of the total flux is always 1.5 maximum flux. But it rotates in space, such magnitude field is called RMF. Why the RMF? Here the current is rotating in the rotor. That depends on the angle. The whole process is called a rotating magnetic field. Thus exists fixed relation between frequency of AC supply to the windings, the number of poles P, which winding is wound, and speed n RPM of the RMF. That is RMF N is equal to 120 F by P. 120 F by P. The next very important concept, construction of three-phase induction motor. There are basically two parts. One is a stator, another one is a rotor. Here stator is always stationary part, rotor is always rotating part. That is a mechanical load through the shaft called rotor. The first, stator. Just see the figure, stator. Discuss the construction of stator of three-phase induction motor. The stator has a laminated type construction made up of stampings. Just see the figure, stampings. That thickness is 0.4 to 0.5 mm thick. The stampings are slotted on its periphery to carry the stator winding. Here the stampings are insulated from each other because of to reduce the some losses, minimize the some losses. That is stampings. The number of stampings are stamped together to build a stator core. The built-up core is then fitted to the cased or fabricated steel frame. Finally, this is a protection purpose. It is a fabricated in the frame. The choice of material is stampings is called generally silicon steel. The minimize the hysteresis loss. Why minimize hysteresis loss? The losses will be produced because of some protection that is called frame. Okay, the next rotor, second part. The rotor placed inside the stator, the area between the stator and rotor, that is 0.4 mm to 4 mm. This is very, very important. Just see all of you. The rotor is 0.4 mm to 4 mm. The two types of rotor again. First is squirrel cage rotor. Second is slip ring rotor. I will explain first the squirrel cage motor. Here the rotor bars, the conductor bars, a slot to slot. Just see the end rings. These are the two end rings. This is a different copper of aluminum bars. Copper or aluminum bars. The rotor consisting of uninsulated copper aluminum bars called rotor conductors. The bars are placed in the slots. These bars are permanently shorted at each with help of conducting copper ring called end ring. The bars are usually branched to the end rings to provide the good mechanical strength. Why the branch use? Because of good mechanical strength. The entire structure looks like a gauge, the forming closed electric circuit. So the rotor called squirrel cage rotor. The bars are permanently shorted to each other through the end ring. The entire rotor resistance is very small. Hence this rotor is called shorted circuit rotor. Because of resistance is very small, the name is called short circuited rotor. Okay, next, slip ring rotor, second one. In this type of construction, rotor winding exactly similar to the stator because of here 3 phase and 3 slip rings. Very important, that is RYB. With the external resistance will be adding. The rotor construct laminated and slotted. The slots contain rotor winding. The 3 ends of 3 phase winding available for connecting the windings in star or delta are permanently connected to slip rings. Okay, thank you.